Let's find a third degree Taylor polynomial for tangent. F of x equals tangent x. So we'll start. We have the function written down. Let's take some derivatives. We know the derivative of tangent is secant squared. So now I need to take the derivative of secant squared. And let's see, the power rule says that would be 2 times secant, take 1 away from the exponent, times the derivative of secant, because of the chain rule. All right, so that's 2 secant squared x times tangent x. I missed an x, even though I managed to say it out loud. Oh well. All right, here we go. So now I need one more derivative if I'm going to have this third degree Taylor polynomial, because the third degree term is going to come from this third derivative. And here I have the product of two functions, so I'm going to have to think about using the product rule. So I have the first function times the derivative of the second function plus the second function times the derivative of the first. So let's see, that's going to be 4 secant x times the derivative of secant, which is another secant tangent. So I'll end up with a secant squared tangent x. And let's see what happens. That's a 2 secant to the 4th x plus 4 secant squared x tangent squared x. All right, so I have all of the derivatives I'm going to need, but I realized that when I wrote this problem on the board, I omitted a very important part of the instructions. Find a third degree Taylor polynomial for f of x equals tangent x centered at x equals 0. Those are a very important set of instructions for the problem because they tell me what to do next. So we're going to pretend that was on the board from the beginning, and I need to evaluate the function in these three derivatives at 0. Well, tangent of 0 is 0. Secant of 0 is 1, and 1 squared is 1. All right, the second derivative, well, tangent of 0 is 0. 0 times anything is 0, and then the third derivative. All right, well, I have 2 plus 0. All right, this third degree Taylor polynomial, 0 plus 1 over 1 factorial times x to the first, plus 0, plus 2 over 3 factorial x to the third. So let's see, I have x plus 2 over 6 is 1/3 x cubed. There's my third degree Taylor polynomial for tangent. Well, my goal here, or our goal largely with a Taylor polynomial, is to have something that would at least approximate our function. So here I have a graph of tangent, and over here I'm ready to look at a graph for x plus 1/3 x cubed. And so what I see here is a function that's doing a pretty good job of approximating tangent at least near 0. And I think I can imagine what's going to happen if I added more terms to this Taylor polynomial, that it's going to get closer and closer to this middle part of the tangent graph. Of course, not doing anything out here. So that even gives me an idea of where, if I wrote out the entire Taylor series, I think I know where it might converge.